Okay, so this week we're going to talk about Numpy, Scipy. We're going to use these links for documentation, etc. You don't have to go read everything at these. These are just quick URLs for you guys to be able to click on and get access to stuff. You will eventually see the videos. That's what we're recording. So we'll have the first one here today and the second one as we go through and play with those. I will move these older videos down here to old videos, so you guys will be able to reference back to those and see those. Just remember, always try to use this year's first and then use the old ones to kind of help you understand if you're missing something or etc. So this week will be the first week that we have our mini project, and we'll again go through getting started on that. We'll work all the way through. And then on the quiz one, you'll have your first quiz down here this week as well. Okay. So let's take a look here. So the first thing we're going to talk about is Numpy. And so Numpy is a package within Python that we're going to explore a little bit more. And it's really used for some scientific computing and dealing with what's called a multi-dimensional array object, right? So most of you may have been played in other languages, and they typically have arrays versus Python, in which we call them what? Does anybody remember what we call them in Python?
A list.
List, right? Yep. So in using an ND array, which is what the NumPy package is based on, N is a n-dimensional array of homogeneous data types, and those operations are used for doing different scientific things. But the main thing there is that when a NumPy is created, it has a fixed size at creation, but unlike a Python list, which can grow dynamically, changing the size of an ND array will create a whole new array and delete the original. All right. So if we look at these little examples here, if we have C equals an empty list and we say for I in the range of len of A, we can append all this information up to this list. Okay. You guys may have seen something here that is there's some inefficiencies in doing with what we do with Python, and that if we were doing C, it would be super fast and it would look something like this. Okay. NumPy, the main reason we use NumPy for arrays and such is it is extremely fast when dealing with very large data sets and very large piles of information. Okay. So if we're dealing with scientific data and we want to be able to crunch these large arrays, if we do simple for loops, Python, it has some issues and it slows down as it goes through that. We do not have that issue within NumPy. So let's get started with a new project in PyCharm. And so to get started with that, let's go ahead and start back out on our GitHub. So let's go GitHub. And you guys should go ahead and start one with your mini project, whatever. So let's see here. We're going to go to new. And in our repository name, let's go ahead and call this mini project 1. And remember to do your full name up here, not just initials. All right. We'll make sure that we leave that as public. We're going to add ourselves a README file. And on the get_ignore template, let's go ahead and set that to Python. So we're going to do all of our basics to get up and going here. There's Python license. We can go ahead and leave that blank. We'll create that repository. And then remember, you would come up here to code and copy your URL for this one. We'll launch PyCharm. Now, we're going to be playing within this project name of Mini Project 1, and we're going to do things that aren't quite the project just yet, but use it as a place to play in PyCharm with NumPy and Scipy. And then we will want to remove those pip packages before we go and continue on. So this is where we left off with that example project the last time. So we'll go ahead and close this one. Let's see here. Let's close tips. And Close our project. And in our new project, let's get from VCS. We'll paste in our URL for our project and hit clone. All right, so here's our PyCharm. And remember, when we first create or pull in a new project, by default, it's going to choose the system level interpreter. So we need to configure our own. So we'll go to add interpreter, add local. And in our base interpreter, make sure we pick our 312, that everything else is set up. We don't have to touch anything. Now, over here on the left-hand side, you have a couple different environments. You have a virtual environment, right, which is what we use by default. You also have what's called a Conda environment, all right? Now, I don't have Anaconda installed currently, but we're going to talk about that. And so Anaconda is essentially a package of Python along with several other packages that are typically used for scientific purposes of doing data analysis. So if we come out here and look at our Blackboard shell, you're going to see we have our Numpy documentation. We'll have our Scipy documentation. Let's go ahead and bring that out to the side. Now, Scipy is very similar to Numpy, only it's going to have very specific packages that scientists would use for mathematics, science, engineering, things like that. So if you're needing to do some advanced math or science calculations, or even engineering calculations, load calculations, etc., within Python, you're probably going to use these Scipy packages, which will also use the Numpy package as well. There is an entire distribution of that is packaged all that together that most people would use if they're in that field, all right? And that is called Anaconda. So Anaconda is just Python at a certain version with a bunch of pip installed packages all set up at the same spot, okay? So if we look at our solutions, you're going to see something like the data science. What we're really caring about is this Anaconda distribution for Python. And this is a free distribution that you can install. It has all the fundamentals for data science, artificial intelligence, machine learning, etc. Those packages are all built into Anaconda by default. So you're going to see some of these big names over here on the left. And ones that we will deal with in this class is Scipy. Obviously, we just talked about that. Numpy is one that's built onto there. We will eventually use things like Pandas data frames, right? And then we will also use matplotlib in order to graph out all of our data sources. So if we want to build pretty little graphs, we will use matplotlib for that. Other ones that people might use, TensorFlow and PyTorch, those are typical with machine learning. Jupyter is typically considered Jupyter Notebooks, which is where you're using the Python interpreter where you can interact with the data that you're wanting to do in real time. So it's no different than coming down and building out a Python package and using the Python console down here at the bottom. It would be the same way. It's just a live console that has access to all these other packages in between. So if you see Jupyter Networks, or not Jupyter Networks, Jupyter Notebooks, it's basically like having a Python shell that has everything built in, including things like matplotlib, so you can graph things dynamically and move through. So Conda itself is just an open source package that's built out just like Python that you guys have been using. You could install Anaconda, and I was kind of showing that in the past where you would install this. So you'd come down to the graphical installer, and you can go ahead and install that. And then inside here, you would pick your Anaconda environment, which would automatically find that executable. In this class, we're just going to show you the particular packages we care about, Numpy, Scipy, Matplotlib. We'll install those by default. So we're going to go ahead and just choose virtual environment and go ahead and hit OK. But I want to make you guys aware of that. A lot of students were saying, hey, I've heard of Anaconda. What's it all about? It's really just a custom tailored package for scientific research, particularly if you're focused on data visualizations like robotics, etc. You would want to use this as a whole. It has all these packages already installed into it. But we can build our own distribution of this for only the ones that we're interested in, which is what we want to do when we are writing code out here. We don't want to have to install this massive Anaconda package that has all these unnecessary things that we may or may not use. So that's the difference between them, is if we use the basic Python and then add the packages we want, the overall install is significantly smaller than the base Anaconda package, which has everything included. It's basically the scientific kitchen sink at that point. All right, so we have this up. We still have our README. That's all looking good. Remember, the first thing we want to do is come into our get ignore, scroll down to the bottom, and uncomment out the .idea. What that's going to do is make sure that none of our PyCharm files are being saved out to GitHub. So let's go ahead and do that. And then in our README, we can just leave this the default for now because we'll really update that all at the end. So let's do a commit and just make sure all of our GitHub stuff is working correctly. On this one, we're going to say add PyCharm to .getignore. Okay. Remember, we always want to do a commit and push. And then a push. Okay. And then down here at the bottom, we can do a Python console. And this Python console takes us to this interactive console. And again, this is very similar to what you would see with Jupyter notebooks, only some other packages would be installed in there. If we go out to the terminal, again, you always want to make sure this VENV is at the front. That means that we're using the correct Python interpreter down here at the bottom, all right? And then you guys would remember that if we do pip install whatever, then we would go in. We would also use pip freeze greater than requirements dot text. And what that's going to do is take all of our pip installed packages and list them out into the requirements file. And for now, if we look at a requirements file, you'll notice nothing's in there, right? Remember, if we want to add this requirements file to our repository, we need to go ahead and right click on that, go down to Git, and you could commit the file. And then we could say added empty requirements.text. Okay. And of course, there's nothing in there, so it kind of complains. It doesn't let you commit it just yet. Actually, click this button up here. There we go. And then you can go to commit and push. And that was a little too many D's on the committed, but that's okay. And push. So all that's going to do is get your requirements file in there. It's good to do that or be in the habit of doing that, even if it's empty for now, so that you don't forget to do that at the end. A lot of students tend to forget that they got to do their requirements file. Okay. So again, you have NumPy and SciPy. Because this is not a computer science class and I'm not diving too deep into these particular packages, right? I'll show you the loops. When you go into the quiz, the main thing I want you to learn is how to set up the basics of a NumPy array. So a NumPy array is going to look something like this, where we have a list of lists that come through there, this, right? And the class we want to use is called an ND array, right? So an example of this, or how we would create that, is to import NumPy as NP. Well, to do that, we need to come back out here to PyCharm, and we need to pip install NumPy. So pip install NumPy. For the sake of this, I'm going to move this to half my screen. Just this side of our documentation. So this make it easier for the recording. Okay, so we got NumPy. We can also check our packages. look at our installed, and we can see Numpy is installed and going. So to start a new file, again, you click on here in your folder at the top. Let's right click, new, and Python file. And in this Python file, we're just going to call this main.py for now. So just say main, and that will automatically call it main.py. We're going to add this to our repository. So go ahead and add. And then we're going to just follow along with this example so we can get an idea of how this works. All right. So import numpy as np. Okay, that imports our module. And it's important when you're importing these packages that you import them in a way that they ask you to do it. So for example, notice that we're importing numpy as np so that we don't have to type out numpy all the time. We just say np. The reason that we want to do this is a lot of scientific results and things like that. One, they're always trying to keep the import modules small. And two, if you find example code on the internet, you're always going to see this np dot whatever, and you're trying to figure out why it doesn't say numpy, right? So one of the things that you'll notice in your project is right up here, 5 out of 5 points is making sure you do the proper import of the packages used, which means if you're using NumPy, you should have import NumPy as NP. We'll talk about the other ones as we go along here. Okay, so now we want to create this array in NumPy. So we're going to have A equals np dot arrange, and we're going to do a range of 15. Okay, and then we're going to reshape that 3 by 5. So what does that actually do? All right. So we hit enter. And if we were to look at this array and notice that they're using a Python console, which is actually kind of easier to use when we're doing this. So let's copy this right into a console like that. And if I want to look at A, we can see that this array is 15 numbers, right? 0 to 14. If you guys remember the range, it goes up to, but does not include, starts at 0. So we have 15 numbers, and these are just generic data for the time being. That's why we set this up. And we want to reshape that in that we have 3 rows of 5 values, right? So that's what this is meaning. We want to create an array that has 15 total numbers in the shape of 3 rows and 5 values in each one of those, or 5 columns, if you want to look at it that way. 1, 2, 3, 4, 5. All right. And so if we want to get a shape back out of this, or we want to get a value out, we would give it the row and column. So a.shape is going to give us back our shape size, which is 3, 5. If we want to get back what type these numbers are, you could do a.dtype.name. And by default, we don't just have numbers in Python. We also have different things. And so in this case, these are integers, and these are 32-bit integers that we're storing. What's also handy is if you do this out here in PyCharm, you can see I have a equals. That's because I set this value up here at the top. If I click this down arrow, I can also see all this extra information about that thing without having to actually test it over here. So this is really handy when you're playing with some data. So for example, if I want to see the minimum, it's 0. And then if I want to see the maximum, it's 14. Note that it's telling me right here that those integer types are in 32s for each one of those. So I can do the date, I can see the shape, I can see the size, and I can see the total array here if I wanted to play with the array itself. So array 0 is going to be the values from 0 to 4. Again, each one of those has a minimum, a maximum, a shape, in which case you just have 5 comma, and then the total size there. So lots and lots of values you can pull out from an ND array. All right. If we want to create our own array based off a given set of numbers, right now we just created some generic arrangement here, right? So here is, given that we have a list of 2, 3, 4, we have a regular Python list or tuple, whichever one. We're going to use a equals np.array. And then inside this, we're going to pass in our list. So 2, 3, 4. All right. And now with this new a that we have there, we can see that it is just a single array, 2, 3, 4. We can see the minimum is 2, 4 is the maximum. The shape is 3 by, meaning that we just have those 3 columns going through there, and that our type is still int32. Notice that doesn't match over here because this particular one is set up to use int32s by default. Okay. If we had a different array, so b equals an np array, and then we fed it some floats, etc. So 1.2, 3.5, 5.1. And again, those need to be in a list. And if we look at B over here and see how it compares, we can see those are all using floats in there as well. Okay. When you're passing this through, you cannot just do a 1, 2, 3, 4. Remember that you have to pass it an actual list. So you want to pass in the colon or the colon, the square bracket, 1, 2, 3, 4. All right. So as you are working with a list over here in regular Python, the moment you want to convert that to a NumPy array, you just take whatever that list is and you convert that using this np.array, and then you pass in that list, right? Again, the reason that we want to do that is that allows us to immediately calculate things like minimum, maximum, the shape and size of it, the type of integers, and it's also extremely fast when we do processing on it, okay? Where in a list, we would have to write special functions to figure out which one's the minimum, which one's the maximum, how many values there are, all that kind of stuff. We'd have to write functions or use different methods in order to do that. We don't have to do that when it's a NumPy array. It already has those particular attributes already associated with the array itself. All right, so I'm going to full screen this back out here. And when you want to print an array, if you say A, you're going to get this little array like this. If you want to reshape it and rearrange it, you could do that here in order to see that. This is really handy when you're dealing with massive data sets, something like this, that maybe you want to reshape that in a way that it fits out the way you want it to. Okay. They're going to go into way more detail about using, doing signs and things like that you probably haven't done since early math class. I am not wanting you to go back to geometry and do a bunch of different coefficients and things like that within data science. We're not quite doing that. What's nice is you can pass this entire array. If you call something like sum, it's going to add up everything that was in the array. You can get the minimum value, the maximum value out of there. That's really what's of interest to us, because we're going to be dealing with number data sets. And in this case, we're going to be dealing with stock numbers. And so this is a really fast way for us to find the minimum value, the maximum value, the sum of all the different things that came through there, and doing slicing and everything else you're used to doing with it. So if you were going to be doing some advanced data science within Python, I encourage you to play and work with NumPy. Again, you're going to have SciPy. This is a great little article here that explains what the difference between those two are. So the main thing is that SciPy builds on NumPy, and that all the numerical code resides within SciPy, and the SciPy module consists of all the NumPy functions, all right? However, it's better to use the fast processing of NumPy. So what it does is NumPy basically uses all the concepts of, SciPy uses all the concepts of NumPy and puts it into arrays so that you have all of its shape, its dimensions, and the speed inherently that's within NumPy, and be able to use that as opposed to SciPy, which is just straight Python. So it's going to have slower execution speed, but a lot more functionality under the hood. All right. NumPy is purely wanting to work with fast computational numbers. Notice that nothing we're doing is dealing with strings, right? This is all dealing with integers and numbers and data science. We have to make sense of what this information really is. And that comes later on. And the reason we would use data frames such as pandas, in order to describe that information a little bit better. It kind of makes it feel more like a dictionary at that point. All right. I know that's a lot of information in a short amount there. Does anybody have any questions? Okay. All right, that's also going to take us into matplotlib and how we would do that. So let's take a look at matplotlib. And so matplotlib is some graphing software, or basically a graphing package for Python that allows us to print out fancy graphs. So for example, in this very introductory one, we would have import matplotlib as pyplot. And so we want to put that in at the top of our folder here. We can see that. Now notice when I put that in that matplotlib is underlined as red. That means that we don't have that package installed. So we need to go back to our terminal and we need to pip install matplotlib. So let's go ahead and do that. And this comes back to you have to make sure that you import these correctly. So notice this one is using matplotlib.pyplot as PLT. So anywhere in our program, we need to call it as PLT, and it will assume that we're calling matplotlib.pyplot. Same way with numpy as NP. Each one of these has their own kind of unique imports that they pull in. So you'll see it's also installing some extra packages here. So you're going to have things like 6 pipe parsing. Pillow allows us to work with graphics, right? So this is going to allow us to deal with JPEGs, PNGs, things like that. That's what Pillow is all about. And then you have a couple other ones here that are going to help us put stuff together. All right. So I don't make you guys buy a textbook in this class, right? And the reason for that is I want you guys being familiar with how to go find this kind of stuff in the documentation for that said package. So let's work through some of the examples they give you in PyPlot so we understand how to do matplotlib. So over here we have plt.plot, and then we are going to pass in a list of 1, 2, 3, 4. Right? And then from there, we're going to have plt.ylabel. And what this is going to let us do is set the label for this. So we're going to say some numbers. And then we always have to run the command plt.show so that it actually gives us the graph. Okay. Now, if we run this little quick program using the run mainpy up here at the top, nothing will happen down here. Oops, I mistyped it there. Sorry. Let's run this again. You'll notice nothing happens down here, but you should get a pop-up of that photo coming over here on the right. And if I full screen this up a little bit, over here on the right, you have SciView, and this is probably something you're going to want to map so that you have access to the scientific view of this. So let's scroll this over a little bit. You have data at the top and you have plots. And this is where it's going to show you those graphs that you created. So by default, it's going to create a 640 by 480 PNG, and it's going to have some numbers. Notice this was our Y label, so we could set a Y axis for what we want, and that we have those numbers going up 1, 2, 3, 4, all the way through. Notice it automatically put in these half steps. So 1.5, 2.5, 3.5. Later on, we can specify whether or not we want that or not as it goes across there. And then notice on X, it starts at 0 and goes up to 3. Does anybody have any ideas based off what we fed it here, why it would do this? Or what number, or how did it get this number?
Is it the index of the list?
Yep, exactly. So it took this first number, which was 1, and that's index 0. So that's why we have 0, 1. And then the next one over was 1, 2. There's our spot. 2, 3, going on up all the way through. Yep. So if we don't specify what that x-axis is, it's just going to use that index as a reference point. Okay. All right. So we may want to set different numbers going through there. So for example, on our X data, we might want something like 14916. And we probably just want 4 numbers going across there. So we could say value 1, 2, 3, 4. So if we pass in pyplot like this, notice the first one, zoom this back over here. This first one is going to be your x-axis. The second one is your y-axis, right? And so we have a Y label here. Let's go ahead and call an X label here as well. So plt.x label. And on this X label, we may say this is our values. And these are our numbers still, something like that. So we'll run this again. And you'll notice we got a different graph that popped up over here. And this time we can see that it's obviously not a straight linear graph, that we're actually going to tail up because of the way those values were displayed over here. So we went 1, 4, 9, 16. Notice how it went faster and faster. At the bottom, we still have our values of 1, 2, 3, and 4. Again, it put these half steps in there just to make this graph look a little smoother. And then going up, it counted by 2s just based off the amount of information we needed to squeeze into the graph. All right. You can format that graph however you want to format that, right? So if we look at this and we say RO, what RO is going to allow you to do is set those out as plots. So it's going to change how you're going to write that. In this case, it's going to use red circles for each one of those. So the default for strings is this B-, which is a solid blue line, right? If we wanted to do plots, we would just pass in RO, and that would give us red dots. So we could change that real easily. For example, I come back here, go to RO, and then we could set an axis number here too. So those are the actual dots that we want to plot. So plot dot axes and 0. And of course, we got to pass this an inner tuple, right? So 0, 6, 0, 20. And what that's going to do is set our outside bounds. So we're going to start at 0, and our biggest bound is going to be 20 and 6. Notice that we put those numbers in here. Okay. So 0, 6 out here, and then 0, 20 as it comes up. 20 being, or 26 being the largest set. It allows us to set what we kind of want these numbers to end up being. So if we run this, notice now we have a preset of 26 going across, and we have those dots going up. Okay. That axis function allows us to set our x-min, our x-max, our y-min, and our y-max. All right. So you may want to do more than what your data actually is. For example, going this way, we only had 4 numbers. Maybe we want 6 to show up here as our overall numbers. Maybe we don't want it to cap out at the very top like this graph did, right? We want it to cap out somewhere below this max line. And that's just to make this a little more readable as we go through. Okay. Obviously, we can't do any numeric processing with just lists, right? And so generally, you'll want to use some kind of NumPy array. And that allows us to build out some sequences or dashes, etc. So what this example is showing you here is we could have a evenly spaced array that starts at 0 and then 5 point and then 0.2. That's setting up the different range. And then we can plot this out with T's. T's going to be the dashes. You have R dashes, which is a red dotted or dash line. You have the T times 2, which is going to do these triangles, etc. Right. Lots of different ways that you can break that data out. You can use these NumPy arrange. So what that would mean is it would allow us to build a giant scatter plot like this, where the dots are bigger based on the amount of data that's coming in there. So they're sized off the data that's coming in. We can also do categorical groups. So maybe you want to do some categorical plotting in which you have groups A, B, and C, and you want to plot those on a single graph. And you may do that as a bar chart. You may want to do that as a plot. What am I looking for here? Single points, or you want actually a line chart going up there, and you can see those different charts. So you have a subplot 131, you have the bar, which is going to see the bar chart and plot, and you always end up with this PLT show at the end. If you leave this off and you execute this code, oops, sorry. You try to run this, you'll notice that nothing happens down here other than it says processed, but nothing printed and actually showed up here on a graph. It's because you probably forgot plt.show. Okay. And again, there's all sorts of these options that you can play with on Matplotlib. So whether you want to set up different figures, you want to make it look cool with some graphs, etc., you can change all this. And we're going to actually work with that. And same way with our text, we have our X label, our Y label. We can actually set the title of the entire graph. And maybe we want to set up a text that shows up in the middle here so we can see where this text is going to show up and then what you actually want it to print. Notice that this is a raw string going through. So it wants the sigma mu equals to 100 and sigma a is going to 15 there. All right. And we can set those extra graphs. If we want to color that data, we could also use something like not just X label data, the font size we want to use, and the color we want to use. Okay. Lots of information there. So we can build all these cool graphs. What we want to do is go back to our project here. And we want to take a look at the Y Finance package. So let's open that up. All right. So this Y Finance package is allowing us to access Yahoo's Finance API. And this Finance API allows us to pull information about different stocks. So we're not going to use necessarily Conda. We just want to pip install for our required packages, right? And the first thing we're going to deal with is this ticker module. So let's go back to our project. And what we want to do is go ahead and keep NumPy and Matplotlib in for our project. We need to install our Y Finance. So let's go to terminal and we're going to pip install Y Finance. And again, this optional piece they're saying here is if you wanted very specific options to repair or something like that. We're not worried about that. And for now, I'm going to go ahead and remove this stuff. This is just us playing around, learning how to use it. We can go ahead and clear out these pictures, our graphs. You can also click on this side view over here. That will slide that off to the side. You can always pull it back by clicking on side view. Should be building the rest of this out. While that's building out, let's take a look at the quick start here so we can get an idea of what we want to do. So we know that we need to import Y Finance as YF. Again, that's the industry standard for that package. So you will need to make sure that you are using those accordingly. Now, these little, whatever that is, yellow squiggly lines, that's just basically saying that you're not using that. You imported it, but you're not using it. So we'll wait for that to come in. And you'll notice with Y Finance, it's again installing a bunch of other dependency packages. One of those dependency packages is actually Pandas, which we'll talk about next week, as well as Beautiful Soup and some others coming in. Requests, you guys are familiar with that for APIs. So we're actually using the Y Finance API as it goes through. So we could go out and get their web API, right, which would have a bunch of gets or posts and things like that. And then we'd have to write out our own functions. This project is based around Python and has those functions built in. So for example, we can set a ticker to this particular title, which we're going to steal this information here just for the time being. And we're going to paste that in here. So we're going to call a variable MSFT. We're going to call the Y Finance package, and we're going to use the ticker module in order to get the information about a said ticker. And this ticker, if anybody doesn't know anything about finance, all stocks have a given ticker on the trade platform. So whether that's NASDAQ, etc., they all have a trade ticker. And you would paste that in here. And you can always look those up. So for example, if we wanted to say Tesla stock ticker, we could see that the Tesla stock ticker is TSLA on the NASDAQ trading platform, right? So we can come back and play with that one here in just a second. Okay, so we're pip installed, and we want to get all this information about msft.info. And then, of course, let's go ahead and print that so we can see what comes out of there. So this simple little example is going to create a variable called msft. We're going to go pull all the stock ticker information, and then we're going to print all the information we get back about it, right? And this has a method called info that's going to allow us to get all that and gather that. So let's print that real quick. And if all goes well, we should get back a pretty sizable amount of information. There we go. Okay, so we got all sorts of information here. And you'll notice this is a very large dictionary that came back. It might be easier to pretty print this. Another option, because we're kind of just wanting to figure out what kind of data we get back for now, we could just start a new Python console. So let's go ahead and close this console, start a new one up. And let's go ahead and call our import package. Sounds good, Eve. So we have our import package, and that came in. We're going to go ahead and set up our Microsoft ticker. And if you look over here, we can now click out and see what all this information is. So if we look at this one here, which again, it's got a lot of information in here. We could just say, there you go. And if you come down here and we look at info, you can see that we can get back things like the address information for that particular sticker or stock ticker, the city, the state, the zip code. You can see what sector it's all in, the total number of full-time employees. You can get all sorts of information about this particular stock. What is the current open on this stock ticker? What's the age of it? What's the payout ratios? All just volume, all things that you might be interested in if you were looking to bid on this ticker. So right now the bid is sitting around 406.31. The ask for people selling it is around 406.27. And you could see what the average ask size is, bid size, etc. You can see all sorts of stuff that comes in here too. You can get out all the options that are available for that particular stock ticker. If we look at news, you can see we can get links to news articles related to this stock ticker as well. So tons of information is coming back on this particular one. Notice that our ticker, aka .ticker, is going to give us back the MSFT. Okay. So lots of cool information. Let's see what else we can see over here on the documentation for it. There we go. And that's what it's explaining here. So you can get the stock tickers, you can get the full share counts. If we wanted to get the market history data, which might be of interest to us. So let's go ahead and do that. And that is at a period of 1 month. So we're going to create a variable called hist, and that's going to call the .history in a period of 1 month. And we'll close this down, look at our hist, and you'll notice that we get back a data frame, and that data frame is going to give us the close, the dividends, the highs, the lows, the opens, a bunch of information that we may want to pull that back at. All right. So we're going to dive into that a little bit more. Notice that because this is an array, we can also call our shape, right? So if I call hist.shape, that gives us back that shape. So it gives us 21 by 7, right? So that gives us 21 entries of 7 columns that go through there. Let's see here. The total size, there's 147 entries in there. And D types, which are going to give us floats for all the opens, close, and all that kind of stuff. Great. What else can we get in here? You can see the financials. You can also pull that out. We could also have the option of doing multiple stock tickers all at once. So if we said tickers and then yf.tickers as opposed to ticker, what that's going to do is allow us to call a string of multiple tickers inside of there. Then to access the information for each one of those, we would have to say tickers dot tickers and then pass in, it's like a dictionary, right? And then we pass in the list or the index of what we want, in this case, the key value. So we could say for Microsoft, give us .info, for the other ones, give us whatever. If you want to download all the price history for those into one table, you could say yf.download and then pass in the two stock tickers and the time period that you want to pull it in. Okay. Those are mostly the pieces that we're going to be dealing with in just this first homework assignment. So let's come back out here. Sorry, let's pull up our homework assignment here. Let's take a look at what we have. So let's go ahead and just copy this into our homework assignment so we can read it, make sure we got it all. And I'll have to reference back and forth. Let's put this up here, paste that in. We're going to go ahead and comment all this out so we don't have to read it. So if we go to code and down to comment with a line comment, it does it all for us. That way we don't have to type in all the hashtags for that. And that will get us started. So first 5 points is our initial comments with our name, class, and project at the top of the Py file. Well, that's a copy and paste. So let's go out here to our content. Copy and paste this in. Okay. And on Jane Doe, you would put whatever your name is here, something like that. Okay, 5 points, pretty simple. Next 5 points, make sure we do the proper import of packages used. Notice right now I'm only using the Y-Finance package, right? So if I don't end up using these two packages, I do not want to import them in because I don't want to add those to the package if I'm not going to use them. Then it says using an API of your choice, in this case, we're going to use Y-Finance, collect the closing price of 5 of your favorite stock tickers for the last 10 trading days. Okay, so that means we got to dig a little bit in this API in order to get the information we're looking for. For now, let's see if we can just deal with collecting one stock ticker, right? So in this case, we're going to have a list of our tickers, right? And we need to have 5 of these available. So the first one, we're just going to say MSFT because that's the one we know. Okay. And then from there, we need to get the closing price for the last 10 trading days. All right, well, let's see if this API has anything that can help us get that. So we know we can do a period of 1 month, right? This is just going to show us a share count. That's not quite what we're looking for. There's our chain option. That one doesn't really help. This pulls our scrapers, pandas. All right, so let's dive into this a little more. A lot of times this can be easier. Notice this is just the overall quick start. Let's go ahead and look at the code for this particular thing. If we go to homepage, takes us out to our Y-Finance documentation. We can see that quick start is basically what we saw in the other one, right? Smart scraper, pull down. We want the documentation. That should be, a lot of times you can check if there's a wiki built out for it. This one doesn't seem to have a wiki. Let's go back to our code. Let's see what links he goes out to here. Aha, so now they're going to show us documentation on that. Okay. Dot history, period max. So we know this period, and if we turn max, it's going to return probably all the results. We're probably going to want to look something on this history to give us a very specific history. Let's look out here. And so we know tickers, we have that one. We would want to say something like MSFT equals YF dot ticker. And then here, I'm actually going to call my tickers 0 for now. So it just pulls the first one out. The reason I'm writing in this and this in this fashion, let's just call this ticker, is so that I can run a for loop later. I can just modify my code a little bit, do a for loop through tickers, and it would automatically replace it in. So we could say something like for ticker in tickers, right? That's going to grab me this one ticker, which is what I would put in here. That's ticker. We could say my ticker here. There we go. And actually, we don't need this whole thing. We just need ticker. There we go. Okay. So that is just a Pythonic way of looping through this list, because eventually, again, we have to have 5 of those based on this ticker here. And we need to get that history. So my ticker dot history. Let's see if we can get some more information as to what we need in that history. A lot of times, let's see here. It's not actually going to show that. Sometimes it'll pop up here and allow us to get more context as to what this is really looking for. And it doesn't look like it's pulling enough information for that. So let's type in period. And let's see what we get out of there. Still not giving us the I was expecting. So let's do, usually you can pass in a time. So let's see if we can find that. There we go, period. So period is going to give us a valid time of 1 day, 5 day, month, etc. Right? We also have the interval. Valid days are 1 month intervals. Here's what we're looking for. A start and an end date, right? So let's start with start and end, where we see something like this. We don't want the download. We just want the history with the start date. And we need to put this in the YYMMDD format, or we can pass in a date time object. All right. So for simplicity right now, we're just going to put it in this format. I will show you guys a little bit more about date time objects later on. But for now, we're just going to plug this in. And so we want something that would start on 24. Let's start on 01. And let's start from January 1st for the time being. And documentation is end. So end equals, just copy the same thing. We'll plug in 10 days into that month. That doesn't necessarily mean anything. Let's just pull that. And we're going to call this our history. And for now, let's just print that history. Let's see what we get. Okay. So when we print history, we'll notice that it's got a weird split here. And what this really is a data frame, right? So we haven't talked about pandas data frames yet. So for now, we're just trying to pull this information out. What we're interested in is the closing price of those 5, right? So we need to find the closing information here. Now we can't see all this data because it kind of cuts it off, but we really just want to know what, for each one of those dates, what was the closing column. So if we say for date in history, and let's pass in something like closing. Print date. Let's see what information we would get out of that. Okay. It doesn't know the closing date, right? That's not a valid key. So we need to figure out what are the valid keys out of this history object that comes up. So easiest way to do that, there's obviously a bunch, but what we're going to do is look at this history here, right? And if we see this, it actually calls it close. So I'm looking at a different object here, but this is the same thing. It has close, dividends, high, low, open, etc. We want just close. So let's set this to close. Let's see what happens there. Okay. This returned us back a series of information that came of all the different closing prices for those particular dates. Now, what we don't have are the actual dates that came out of there. So we would have to go one step further, but for now we have all of those prices. We just don't have the dates that are associated with those prices, right? So we're going to need to dive a little bit deeper into what we see over here. Now, if we look at close, you're going to see that there's the whole array that comes out. It's a whole NumPy array. We want to try to get those dates and times as well as those closing prices. So we got some more work to do. We're in a series. We got to pull it out. That's where I'm going to leave you here. We'll pick back up on this on Wednesday, and we'll see if we can't get further along in this. Then we'll start plotting out the graphs, working with Matplotlib. And then we need to make sure that it shows a minimum of those 10 data points, which it should because we pulled out 10 trading days. Well, you'll also find out a little bit on trading, just kind of as a foreshadow, is that we can't just pull 10 dates because there's no trading information on the weekends because you can't trade on the weekends. Traditionally, you can't trade on the weekends. Nowadays, you can do a little bit. So we will need to make sure that we pull full the 10 last trading days. And that's why I'm pretty specific on trading days. We'll have to calculate what those are and then ask for the history of those particular ones and then shove this all into a array so that we could then use NumPy arrays to pass it into Matplotlib. All right. Austin, Melissa, I know that's a lot. You guys got any questions?
I think I will as we actually get into the plotting of it, but this was great information.
Fantastic.
Yeah, it's just something I digest as I work on the project.
That's exactly right. So that's why I give you guys the documentation stuff in the beginning, but at the end of the day, let's start in on the project, and then you'll be able to learn what's actually happening. So, and we can see this here, right? So we can see the close, we can see the SPY, we can start drilling into what we actually want. So, all right. Long story short, we're doing the long way of doing this. And then when we come back and do pandas, it's like, well, couldn't we just do that beforehand? It's a whole lot easier to play with, but we got to walk before we run.
Yeah, awesome. Thank you so much.
All right. We'll see you guys Wednesday.
Bye.
Take care.